Hey everyone, Simon Mansfield, Solutions Architect here at GitLab. This is part of the Sales Level Up series of videos, and this particular video is on how the runners work. So, let's start off with why you might be asked why the runners work, and we'll go from there. So customers quite often want to know about how GitLab runners work for one of these four reasons. Firstly, there are a piece of infrastructure or service that is actually external to the main GitLab server, whether that be Omnibus or GitLab.com. Customers quite often need or want to run their own GitLab runners. And that will traditionally mean that they're running it on their own infrastructure, whether that be bare metal on-prem or in their own private cloud somewhere online. That normally leads to some other follow-on questions, which is that they have concerns about the GitLab runners and security. How secure are they? They're responsible for transmitting a lot of data back and forth, so they're interested in how that works and how secure that is. They also sometimes have concerns about the maintenance overhead of running these GitLab runners. How hard are they to install? How hard are they to upgrade? How much time and effort is it going to take their team to look after them? And then the final reason why you might get asked a question about GitLab runners is because some customers have very specific application deployment strategies or building strategies that need to be run in a very specific environment. Things like high memory workloads or require graphics cards or other hardware or other locations. Those unique requirements quite often mean that they need to start looking at GitLab runners and hosting them themselves. Okay, so first off, what is a GitLab runner? I'm just going to preface this with, I'm expecting you already to be familiar with how CI and CD works. So if you're not at this point, go back and have a look at the CI/CD video and then come back. So GitLab Runner is the open source project that is used to run your jobs and send the results back to GitLab. That's what it's defined as in our docs. So what does that mean? So what that means is that a GitLab Runner executes pipeline jobs as defined in a customer's GitLab CI YAML file. So as an example, here's a very, very simplistic GitLab CI YAML file that defines a single job called example. It gives it a base image to use. It defines the stage in which this job runs in. So this job called example is running in the stage called test. And then it defines a single script to run, which is the actual execution of the job. And what it's going to do is it's going to simply echo the text, "This is an example," to the command line. That output is then captured by the runner and sent back with the results, which in this case is a success, to the GitLab instance. So that's how you're going to get your green tick on the job on the pipeline page. And if you click on the job, you're going to see this is an example in the logs on your GitLab instance, be that self-managed or GitLab.com. So customers use runners to execute jobs, which in combination form their CI and CD pipelines. The jobs themselves are completely customizable and can perform any number of tasks. The jobs don't the GitLab runner doesn't dictate what a job can and can't do. It's pretty agnostic in that sense. So in answer to the first question in terms of how hard they are to install and also the maintenance burden, you can install a GitLab runner on any platform that supports the Go programming language. We have, however, got really simple installation methods for both Linux, Mac, Windows, FreeBSD, Docker, and Kubernetes deployments. That's not to say that it can't be deployed elsewhere, but those are binaries that we produce, binaries or Helm charts or containers that we produce that make it very, very simple to install the GitLab runner on those systems and also upgrade. The GitLab runner also supports auto-scaling in certain configurations, which means that it can spin up additional runners and also scale back the runners to match the demand, which minimizes both the cost in terms of how much resources are being consumed by the fleet of runners, but also time. It minimizes the amount of time needed to execute pipeline jobs. If there's more jobs, it scales up. If there's less jobs, it scales down. They're easy to upgrade. For most of our binary deployments, so Linux, Mac, Windows, and even the Helm charts, it's simply a case of shutting down the runners gracefully, updating them to the latest version, and starting them back up again. Given this information, you should be able to talk to a customer and demonstrate to a customer that they have the ability to create runners wherever it makes the most sense to their business requirements, wherever that may be. And that the maintenance burden in terms of looking after them is pretty minimal. This is sort of a one-time install. We're going to go over what's next, but again, this is a one-off. The next thing that you need to understand as part of the GitLab runners is they have something called an executor inside them. And the executor is chosen from a list of executors that we have available. And I'm just going to go over what an executor is. So the docs define it as a GitLab runner implements a number of executors that can be used to run your builds in different scenarios. The keyword there is run. The executor is the bit that actually runs the job, and so it defines how it runs and in what context it runs. And that's really the key bit. GitLab provides a number of executor choices: SSH, shells, parallels, VirtualBox, Docker, Docker machine, Kubernetes, and even custom executor choices. We've recently just launched a Fargate custom executor, so that's another one on the bottom of the list there. Don't worry about learning all the executor types. You don't need to understand them in detail. That's the responsibility of your solutions architect. Just know that we have a lot of them, and that combined, they pretty much support every use case that a customer can pretty much come up with. So they shouldn't be limited by our choice of executors. Customers do sometimes struggle to understand which executor they should choose. So my recommendation would be to make use of the bit in the documentations that says, "I'm not sure." There's a link in the slides. Use that. It will go through each of the various executors and explain the pros and cons of each and where you would use one over the other. However, as a rule of thumb, especially in early stage conversations with customers, the default choice should probably be Docker. There's various reasons why that is. I won't go into them. It's long and technical, but Docker is the Docker executor is essentially how our GitLab.com shared runners execute, and so as a result of that, it means that if they use Docker executors themselves when they install, they can pretty much port their GitLab.com projects to using their own runners without any changes to their pipeline and without any changes to their GitLab CI YAML file. So that's why they should do that. So once you've installed GitLab Runner, you've chosen which executor you're going to use. The next step is to register that runner. Everything up until this point has been done on a virtual machine, on a bare metal hardware, wherever you've actually installed the runner. But that runner doesn't know anything about the GitLab server at this point. So registering a runner is the process that binds the runner with the GitLab instance, whether that's self-managed or .com. So in order for a GitLab runner to start processing jobs, it needs to be associated with a GitLab server as one of the following types: a shared runner, a group runner, or a specific runner. Shared runners are a shared pool of runners available at the instance level that process jobs using a fair usage queue. And that means that they can be used for any project in any group within the entire instance. And there's a strategy in place to make sure that one project doesn't really suck up all the resources and not give other projects a chance to run their jobs. This is only available on self-managed because you can't attach to the instance on GitLab.com. The next level down from that is a group runner or a subgroup runner. They're really useful when you've got multiple projects all under one group and they all need access to a set of runners with a similar configuration or an identical configuration. Group runners don't use a fair usage queue. They use a FIFO queue, so first in, first out. So the first project to post a job to the queue is going to be the first job that's executed in the queue. So you can end up in situations where there's contention there for resource. But that is the highest level of runner available to GitLab.com SaaS users. And then finally, the third one is specific runners. So this is at the project level or specific projects. This is really useful for jobs that have specific special requirements. So if they need to run, if a customer needs to run their CD, so their deployment step, and they're deploying to their AWS environment, but their AWS environment is pretty much not connected to the internet at all in almost any way. Sometimes the easiest way to deploy to that environment is actually to run the deployment job within that AWS environment itself. So that's a prime example of where you might want to do something like that. But it's also another prime example of where you might want to make use of a feature of GitLab runners and our CI, which is tags. So you can use tags in a similar way to potentially using specific runners. I would probably recommend using tags over specific runners if you can. But there are certain circumstances where specific runners are required. So that's what they're there for. Registering a runner is actually done from the runner itself. So again, it's done from the virtual machine or the Docker instance where you've actually installed the runner. And you go through a number of steps. You provide it with the GitLab server URL, so which GitLab server it's communicating with. You give it an authentication token that's been provided to you by the server. So this is a two-way authentication. You're saying, I'm on the runner and this is a token that I've got from this server. So I definitely know that the server is going to allow me to connect. You give a description to the runner and you tag the runner. And then finally, you choose the executor that you want the runner to run with, which is obviously the last slide. Once it's been registered, this is a one-off operation. Everything else about the runner can typically be administrated from within the GitLab UI itself. So it's kind of a one-off process, and it's literally a 6-step process, so it's pretty easy. So now you've got a GitLab runner installed, you've chosen your executor, and you've registered your runner. So now you've got a situation where you have a GitLab server and potentially multiple runners connected to that GitLab server. How does it go and get jobs? So we're going to run through very quickly at a very high level how it goes and gets jobs. And this is really to help answer the security question. So runners request jobs over HTTPS and they poll for them continuously. So a runner will basically say every 5-10 seconds, it's customizable. How often it basically says, have you got any jobs for me? Have you got any jobs for me? Now you could argue that this isn't the most efficient way of doing it, because you could say that actually a server is aware when there's a job available. The server could say, here you go, runner, here's a job. And that would be more efficient. It would stop having to wait for the next poll for it to pick up a job. But this is where the security aspect comes in. Customers quite often run their runners within their own infrastructure. And so it's much, much more secure from a customer's perspective to allow a GitLab runner within their infrastructure, outbound access over HTTPS. So just issuing an HTTPS request outbound than it is to allow an external provider, a GitLab server, even worse, potentially GitLab.com and the vast array of IP addresses it runs on, inbound access into their infrastructure. A lot of customers would get very, very nervous, understandably, if they had to open up their infrastructure inbound to a large array of IP addresses. So from a security perspective, it's much more secure to have a runner polling the server internally from inside their infrastructure, making an outbound request. So this is how it works. So it polls over HTTPS for a job. The server checks then a few things. So it checks to see whether or not that the token that the GitLab runner has is valid. Where that runner is registered. Is it a shared runner? Is it a group runner? Is it a project? Is it a specific runner? And what tags it has. As a result of all of those things, it knows whether there might be an appropriate job that it can run. If there is an appropriate job, it selects one. The next step is that the server then sends a response to that request as a job response JSON object. You don't need to understand what that is, but basically just imagine it's just a single job. So a pipeline has multiple jobs, multiple stages potentially. The runner doesn't know anything about pipelines or projects or context. The only thing it knows about is a single job. So it's impossible for it to know what came before it or what came after it. And so that's really fundamental to the design. So that job response object just details what it needs to do to complete this specific job it's been given, nothing else. The runner then notifies the server that it started the job. It's possible that it got lost in transit or it suddenly picked up something else or crashed in the meantime. So it tells the server it started it and starts processing the job using the executor that you've defined. So it's then going to run through the script. So this is, in our example earlier, this is effectively, it's going to run that command, echo, this is an example or whatever the text was, to run that command. The next part is that actually, while it's running all these commands, it's actually going to stream the output of the logs from the runner directly to the GitLab server, so that the server has always got in the pipeline view, in the job view, the latest log output from the runner. Finally, the runner is going to notify the server whether the job succeeded or failed. Once it's finished, it could fail with an error code. So if it's a test, it might say that the test's failed, and it will tell the server that. It might be that it's a build and the build succeeded, in which case it will tell the server that. And so that's what determines whether you get that green tick or that red cross. And really, that's it. At a very high level, that is how the runner operates, and it just does that repeatedly over and over and over again. There's a lot more to the runner actually technically deep down inside it, and there's a lot more in terms of caching and artifacts, but at the highest level, that is what it does. And for most customers, without involving an SA, that's perfectly a good enough understanding for you to be able to answer most questions. If you have any further questions that you can't answer and you need to answer them without getting in touch with your SA, there's some additional resources here. So we have really comprehensive runner docs with how to install, how to register, what the various different executors are and how they operate. And then that final link in the slides is how to configure the GitLab runners within GitLab. So this is the other side of the configuration. So within your GitLab server, how you can tag them, how you can move them around, how you can pause execution, stop them, etc. And hopefully that now gives you everything you need to answer your questions. Take care and have a good day.